I won't believe you, but I'm not.
I did nothing to you.
Okay, here we go. Let's start right up here. That's circle J. That's circle J up here. Let me know what RJS is. What type of angle is RJS then? 16?
RJS.
Yep. What do I call that type of angle? Minor and major are for arcs, not angles. RJS, this J is the center, because I called it circle J. If I have an angle where the vertex is the center, that's called a?
Central.
There's never anything called a center angle in here, all right? Central angle, it's called a central angle. That is the only type of angle you are familiar with, okay? That is it, is a central angle. The next third of this unit is probably the toughest part of this unit. So now what am I talking about? The toughest unit and then the toughest part. So basically the toughest all year we're gonna face. We're gonna talk about all the different angles inside a circle. And the only one you know, again, what's it called, Max?
Central.
Is a central angle. Today, I'm gonna introduce a second type of angle in a circle, which is called an inscribed angle. How did I know this was central? Because they met, the vertex was the center. Well, what happens if the vertex is not the center? Now for an inscribed angle, your vertex is somewhere on the circle. So everybody put a point on your circle somewhere. That's going to be the vertex of our inscribed angle we're about to draw. On the circle, on it, not in it, on it, on it. Now I want you to draw the two rays of your angle, but there has to be, take a look, the rays have to be chords. Watch, hey, that's not inscribed. You're coming up short on me. Both sides of the angles have to be chords. So go ahead, draw it in. That is an inscribed angle. The vertex is on the circle and the two sides are chords. Go ahead, name it too, with letters, all right? So now the first piece is, how do you find that angle? Because we knew a central angle. Ooh, we're gonna have to dig deep here. How do I find a central angle? Angle RJS was always the same as, this is quiz stuff too. 19, always the same as? Yes, yes. It's always the same, right? They're always equal to each other. Not true for inscribed. If you want to find the measure of an inscribed angle, you take half its arc measure, everybody. You take half it. All right, so central, we're gonna have to start building this now. Central angle is equal to the arc, inscribed, half its arc. So for me up here, inscribed angle B is equal to half of arc AC. All right, that's how inscribed angles work. They're equal to half its arc. So now keep in mind, you have two different angles now, central and inscribed, and we got a lot more coming down the road next week. All right, we got a lot more coming. Any question on what an inscribed angle is, or two, how do I find it? We're good? Before we do some application of it, let's do it. All right, you guys see triangle ABC, it's inscribed. We know that means the vertices are on there. I gave you 8, angle A is 80, and arc AC is 88. All right, help me find the rest here. How about arc BC, the measure of arc BC? I'll let you take a second to digest here. First one always goes a little rough. Okay, 3, angle A is what type of angle? Central or inscribed? That's how usually I start all my questions here now. Central or inscribed? It's inscribed. So now I go, all right, how do I find an inscribed angle? What's the rule to find an inscribed angle we just had? 23, how do I find an inscribed angle? I take half its arc, right? So 80 is, and I know you guys could do it a lot quicker. I'm just showing you every step. The inscribed angle is equal to half of its arc BC. So I don't want to cut 80 in half. I want to do what with 80 to find the arc? 4? Double it, right? I want to double it. Good, great job. So 160. Piece of advice, time out, piece of advice. We are going to start seeing a lot of problems that go parts A through whatever. D, E, F. Once you find a part, label your diagram with it, please, because it probably will help you out later on in the problem. So arc BC, 160. All right, next up, what about angle B now? Measure of angle B. Look on the diagram for me. 11, what type of angle is angle B?
Inscribed.
Inscribed, how do I find it?
Divide.
Go ahead. 2. Take half its arc, which is?
88.
Take half of the arc, because that's the rule. So angle B, 44. Label it. 44 degrees. Now, this is why I say label your diagram as you go along. Now we go to angle C. You don't need to know anything about circles to find angle C. Could I do an inscribed angle rule? Sure. I could take half its arc, but there's other ways I could get to it. How are you going to find angle C? 17, hook me up here. How do you find angle C?
Triangle is 180, so you add 80 and 44.
Riley didn't say a word about circles, and you can still find it that way. That's why it's so important to label your diagram, because you see that now. 180 minus 44 minus 80. What do we got there? 56?
Yeah.
Yep. So 56. And then you guys here, part D, find arc AB. Again, you don't have to use you can if you want, but so I'm going to let you take over 11. Actually, I just heard from you a couple minutes ago. I'm done. 9. What? Okay, how do we get there? Okay, because 56 is an inscribed angle. Did anybody subtract 88 and 160 from 360? Yeah, perfect. Great work. All right, good. So we're all good there. Oh, today's a big theorem day. Make sure you get a lot of rest this weekend, too, because you know where all these theorems are going to go next week? Let's go. They're back next week. Back. I'll have some music playing, tissues handing out. It's going to be great. They're back. Statements, reasons, givens. Yes. And all these theorems we're writing down are going to go there. In your groups right now, I don't have to say anything. Go ahead. Find the measure of angle ADB and the measure of ACB for me. Or just be silent and don't say anything.
Yo, I got 62. And then we're going to go with... Yep.
I didn't.
All right, going back. Oh, 13. What'd you find out? They're both. Oh, so they're equal to each other, huh? I didn't really care about the 62, to be honest. It was more of the fact that you guys found out that they're going to be equal to each other. What type of angles were ADB and ACB? Those are 22. What type of angles are those? I know that. Thank you. Preferably the topic of today. Okay, so here's theorem number 2 today. Inscribed angles and what did you guys notice about them on the diagram? Inscribed angles. I'm going to use drawn to the same arc. Yep. Now, Pedro, you can hit me up with it. What do you know about them? Arc congruent. Look at you. Yep. Inscribed angles drawn to the same arc are congruent. Anytime. So now, knowing that fact, go ahead, hit up number 3 right now. See what you got with number 3. By yourself, in your group, whatever, float your boat. What are you doing to the 2 here? 13x minus 9 and 6x plus 26. What'd you do to the 2? 11?
I set them equal to each other.
Why? I'm making this kind of like a proof here. Why?
Because they're congruent and drawn
Because they're congruent and drawn to
to the same.
the same. What are they?
They're inscribed angles.
There you go. Inscribed angles drawn to the same arc. What'd you get for the value of x, Brody?
5.
5. Good. All right. That's not my final answer. Tell me what you did with the 5. Oh, 2. What did we do with the 5?
I put it into ABD.
ABD, you got it. So 6 times 5 plus 26. And what was ABD?
56.
56, but I'm looking for arc AD. Right? Not 56. What'd you have to do with your 56?
Multiply it by 2.
Yes, we do. Yes, we do. And we ended up with 112 degrees again. Yep. We're all good? Making sure we're not stopping at x equals 5. Oh, what's that? You wanted a third one today? Third theorem? You got it. All right, AB is a diameter. As you can see, it goes through the center. I want to start with finding angle x. Let's start there. Let's find angle x. First question, what type of angle is it? Central or inscribed? 18? Inscribed. So I know the rule is I take half of whatever arc it's drawn to. Can you guys find that arc it's drawn to? Even if you have trouble, literally just take your fingers and follow the rays until you get to the arc and see which arc you're on.
Yeah.
Name it. Name the arc that angle x belongs to. 22?
Arc AB.
Yeah, arc AB. Right here. Ooh, vocabulary time. We have a name for that type of arc. That's a diameter. That's a diameter. Dig deep here. Dig deep. Haven't been doing too well on this question. What type of arc is it? 21?
Semicircle.
So, whoa, semicircle. Yes. Everyone remember that? And how many degrees in a semicircle?
180.
Buck 80. So I'm going to take half of 180. Great job. That's a semicircle. Half a circle. So angle x ends up actually being a right angle, doesn't it? And that is your third theorem here today. It's already written down here for you. If you take an inscribed angle, draw it to a semicircle, it automatically becomes a right angle. All right, so anytime you see an inscribed angle that's drawn to a semicircle, we automatically put our right angle symbol there from now on. All right, I don't need to show any more work that it's half of 180. All right, so any inscribed angle drawn to a semicircle is a right angle, and then go ahead and find angle y. And just so there's no confusion, 26 degrees is referring to angle D, not arc BC. All right, 26 degrees is the measure of angle D. So how can I find angle y? I got a trap set up for many of you to fall in. Got a nice trap for you to fall in there.
Yeah.
17, how are we finding y?
It's 64.
How you getting that? I'm just asking.
I don't know. I did it with Waisha. Ask her.
What type of figure's in the diagram? What's inscribed in this circle?
Why?
No, what type of figure is inscribed?
Oh, okay.
Okay. How many angles you know already, Rad? How many angles do we know in that triangle? Okay. And I'm looking for the third. Why? So you tell me.
90 plus 58. And then 180 minus what that is.
Yeah. And that ends up giving you?
32. Yeah, right? You said it was something else. No, because. Okay, so I was right.
Believe in yourself. Okay? You don't need help. Believe in yourself. I threw the 26 there because I was hoping some of you took half of 26. That's not an arc. It's an angle. We only take half an arc measure. All right? Not angles. All good? And then your fourth and final theorem today, you're going to draw your own diagram for this. Give me a quadrilateral inscribed in a circle. Go ahead. Give me a quadrilateral. Underneath this last theorem here, you got your circle. Give me a quadrilateral inscribed. Inscribe a quadrilateral for me. And this will be our fourth and final theorem for today. Where do your vertices have to be? On the darn thing, yep. I don't care what the quadrilateral is either, as long as it's got four sides and all four vertices touch your circle. And go ahead and name those vertices. Go ahead and name them. And here's your fourth theorem. If you're given this, a quadrilateral that's inside a circle, opposite angles are supplementary. I know that word hasn't come up very recently. They add up to 180. So first thing is, I know W, in my diagram anyway, it might be different letters for yours. W plus angle B is 180. And the same thing for H and R. H plus R equals 180. So there is your final fact today about circles. And then let's use this theorem and everything else we've used today. Go ahead, see if you and your group, A and B, see what you got in you. Finish this up strong.
What?
186.
180 minus 86.
So this is GE. This is where it's located. This is the arc. It belongs to GFE. Oh, you did this? Yeah.
So the question was about how he died.
The Islam. The Islam battle.
All right, here you go. Let's start with measure of arc GFE. Arc GFE, 23. 23? I don't want the answer. I'm asking you a couple questions before. What type of angle is the 86? Inscribed. And what arc is it drawn to, Maddie? The one I'm looking for. Everyone see that? 86 belongs to GFE. All right, now what do I need to do the 86 then? Double it. And what's the final answer? 172. Thank you. Great job. We okay there? And then finally, what about angle F? 3. Where's it across from? What's up?
Say that again.
Sorry, God. It was an awful question anyway. You got a quadrilateral inside a circle, right? D and F are opposite. What do I know about them? Supplementary. So 180 minus 86, what do you got for me? 94 degrees. Good. Okay, any issues there? Again, nothing to do with the quiz tomorrow. You're not going to see any mention of inscribed angles. So why don't we get our Chromebooks out, everyone? Get on Delta Math. I worry about this. Let's stay on Delta Math. Let's not peruse other websites or get another class doc out. Right to Delta Math.
That was my first answer.
You might need some scrap paper off to the side to jot down some calculations.